Hello everyone, welcome to this session. In this session, we will talk about the parametric machine learning model. As we have seen in the machine learning procedures, right? So we first have a training data set, then we represent them, then we will select machine learning algorithms. After that, we do the model training. So when the model is trained, we evaluate the model. So this is a procedure. And in the last session, we have finished the data representation. This session, we will focus on the select machine learning algorithms. So machine learning models, we can divide them to parametric models and non-parametric models. So this session, we focus on parametric models and use a simplest example, linear regression, to represent the characteristics of the parametric models. So what are parametric models? For these models, we have a known form. So for example, the y and x, the output and inputs, their relation is a line, is a quadratic curve, right? So these are the pre-assumption. So we assume we know this form. Then we want to learn the coefficients to build a good model. So this one, we call it parametric models. So parametric models include there are many models that are parametric models. So for example, the linear regression that we will talk about very soon, and also include the logistic regression and the simple neural network. So those ones are all the parametric models. So let's see the pros and cons of the parametric model. So the advantage is that parametric models are often explainable. So for example, for some physics reasons maybe, the output y and the input x, we may consider this as a, let's say, quadratic relation, right? So now what we are doing is to find the appropriate coefficients to build the model. So then we can explain the relation between y and x in a clear form, right? And also because of this, parametric model sometimes is constrained. So it's a constraint to the predefined form. So because of this, it may generate poor fit sometimes. So for example, the relation between y and x, this is a cubic relation, right? It should be a cubic relation, but the model that I defined is linear. So I try to use a line to represent a cubic relation. So clearly the result won't be good, right? So that is the advantage and drawback of the parametric models. But however, to overcome the drawback, not all of the parametric models have these problems. So later on, you will learn neural networks. It can solve the theoretical mapping from any input to any output. Now we see a case study of the linear regression. This is the typical kind, and it's very simple. So we can see we want to learn the two sets of variables. X is the input and y is the output, and their relation is a linear function, right? Linear function. So y equals to ax plus b. So y is a dependent variable to be predicted, and x is a independent variable or inputs, right? So the inputs and outputs follow a linear relation, right? And we can describe it like this: y equals to a multiply x plus b. So the coefficient a and the intercept b, so these two are the learning outcome. So after training this model, we want to find the optimal a and b to make the fitting the best, right? So in summary, linear regression, we matched one or more numerical inputs to a numerical output. So then we can see an example for the linear regression. We use a previous financial prediction example. So we give the research and development spend, the administration spend, and the location of a company. We want to predict the profit the company is expected to make. So we have 1,000 samples. So we can see here. So to make it simple, the marketing spend, we didn't consider it. So we only consider R&D spend, administration, and state. We want to predict the performance. So as I have said, right, the linear regression, the input must be numerical data. But here, this one, the location is categorical. Now, how to do that? Yeah, so data representation, right? One-hot encoding or dummy encoding if you want. So we can do like this. We provide X with 5 elements. So X1 and X2 are the R&D spend and the administration spend. So 3 to 5, they are what? They are the one-hot encoded of the location. So in this way, there are 5 inputs, and the output Y is a scalar. This is a profit. So we want to learn this model. So in the 1,000 samples, okay, I say I select 750 as a training data set. Remember, the rule is that the training data set should be more than the test data set and is at least 60%. So here I select 75%. I want to learn such a model. Y equals to A1 multiply X1 to A5 multiply X5 plus B in the intercept. So now I need to use some method to find the best A1 to A5 and B, right? So let's see how it goes. I first do the normalization of the numerical data and one-hot encoding of the categorical data. So for normalization, we will talk about in future weeks. Now we can just see it, right? So we can then spend, administration, the one-hot encoding of the location. Then I do the linear regression. So this is the result, right? So we can find out. So by using the A1 to A5 and B, the line is formed. So for a new input with a new kind of R&D spend, administration, and another location among the set, so we can predict the profit, right? So now let's summarize advantages and drawbacks of the linear regression. So the advantages is that linear regression works well when the relation between the dependent and independent variables is linear, right? We don't have the interaction terms. So for example, X1 multiply X2, we don't have such terms. All of them follow a linear relation. So in this case, linear regression should provide us a good result. And also the result is easy to implement, and we can easily to explain it, right? And the training is efficient. The drawback is that linear regression is valid only when the linear relation exists. So otherwise, we can't expect linear regression can provide us a good result. Also, linear regression is sensitive to outliers. So what is outliers? We will discuss in the future weeks. Thank you very much. Bye-bye.